Kerberos is the primary network authentication protocol, securing over 90% of enterprise environments, including all Microsoft Active Directory domains and most Unix networks. A network authentication protocol is a set of rules and procedures that allows systems to verify the identity of users and services across a network before granting access to resources. Kerberos uses a ticket-based system to enable single sign-on access to multiple services without transmitting passwords across the network. The protocol operates through a key distribution center, KDC, which contains two main components: the authentication server, responsible for verifying initial logins and issuing granting tickets, and the ticket granting server, which validates these tickets and issues service access tickets. All of these components work within a Kerberos realm. A Kerberos realm is like a secure administrative boundary for authentication. Each realm manages its own users, services, and policies and has its own key distribution center, KDC. Realms are usually named in uppercase and often match an organization's domain name, such as learnsecuritymanagement.com. Large organizations can have multiple realms, and these realms can be linked so users from one can access services in another through cross realm trust. In Kerberos, every user, service, or host that participates in authentication is identified by a unique name called a principal. A principal typically has three parts: the primary, such as a username or a service name, an optional instance, like an admin role or a host name, and the realm it belongs to. For example, a user might have the principal Gags at learnsecuritymanagement.com, while a service could be host appserver01.learnsecuritymanagement.com at learnsecuritymanagement.com. Kerberos assigns tickets to these principals, allowing them to securely access resources across the network. At its foundation, Kerberos uses symmetric key cryptography to verify users and service identities across unsecured networks. Kerberos makes sure both the user and the service prove who they are to each other, so both sides know they are talking to the right person or system. Instead of sending your password every time you access something, Kerberos uses secret codes called tickets that are created using shared keys known only to you and the system. This ticket system means you log in once and then use tickets to access different services, which is called single sign on. Because passwords aren't sent over the network again and again, your information stays safer. Each ticket has a time limit, so old tickets can't be reused by attackers, and that's why all computers using Kerberos need to have their clocks in sync. Now let's look at the components of Kerberos. The authentication server checks your username and password when you first log in. If your details are correct, it gives you a ticket granting ticket. We will look at the detailed steps of this process shortly. The authentication server is the first checkpoint in Kerberos. It keeps a list of user accounts and makes sure you are who you say you are. Instead of sending your password over the network, it uses secure methods to confirm your identity. This step builds the trust needed for everything else that follows. The ticket granting server gives you access tickets after checking your ticket granting ticket. When you want to use a service like a file server, the ticket granting server, TGS, gives you the ticket you need. There is no need to enter your password again. The ticket granting server is like a ticket booth at an amusement park. After you have shown your first ticket, the TGS hands out tickets for each service you want to use. This way, you can access different services without typing your password each time. The TGS also controls which services you can use and for how long. The key distribution center usually combines both the authentication server and the ticket granting server in one system. In Microsoft Active Directory, domain controllers act as KDCs and handle all login requests for the network. The key distribution center is how Kerberos works in most companies, making the system reliable and easy to manage. The KDC also stores all security keys, so keeping it safe is very important for the whole network. Now let's look at how Kerberos authentication works. The main goal of Kerberos authentication process is to let a user securely access a service on the network, such as a file server, database, or web application without sending their password each time. When a user attempts to log in, their workstation sends an authentication server request to the authentication server in the KDC. This request includes the username and a timestamp encrypted with a key derived from the user's password. The timestamp prevents replay attacks by ensuring the request is current. If the authentication server successfully decrypts the timestamp using the stored password hash, it confirms the user's identity. The authentication server then generates a ticket granting ticket encrypted with the ticket granting server TGS secret key, along with the session key for communication between the client and the TGS. This ticket granting ticket serves as a proof of authentication for subsequent service requests. When the user needs to access a specific service, their workstation presents the TGT to the ticket granting server, along with the request for the desired service. The client also sends an authenticator encrypted with the TGS session key to prove the possession of the legitimate session. The ticket granting server decrypts and validates a ticket granting ticket, then issues a service ticket encrypted with the target service's secret key. This service ticket includes a user's identity and a new session key for secure communication between the client and the requested service. The client presents the service ticket to the target service along with an authenticator encrypted with the service session key. The service decrypts the ticket using its secret key, validates the user's authorization, and grants access to the requested resources. Kerberos doesn't just let the client prove who they are to the service, it can also work the other way around. If mutual authentication is enabled, the service responds to the client with a special message called AP-REQ, encrypted using the session key they share. When the client successfully decrypts this message, they know they're really talking to the genuine service, not an imposter. This extra step helps protect against man in the middle attacks and ensures that both sides can trust each other before any sensitive information is exchanged. Kerberos provides significant security improvements over basic authentication methods. User passwords never traverse the network after initial authentication, reducing exposure to network sniffing attacks. Both clients and servers authenticate each other, preventing man in the middle attacks. Timestamps in all tickets prevent replay attacks where captured authentication data might be reused maliciously. Centralized credential management through the KDC simplifies password policy enforcement and account management. The single sign on capability reduces password fatigue while maintaining security through the ticket based system. Kerberos is secure, but attackers have found ways to exploit it. In the next video, we will look at the most common Kerberos attacks and how to defend against them. I hope this overview helps you understand how Kerberos authentication works and why it is so important for securing enterprise networks. Thank you for watching, and I'll see you in the next cybersecurity video.